Okay, continuing on with our Laplace Transforms playlist, we want to find an expression here for the Laplace Transform of f prime of t, so the derivative of some function. We don't care what it is right now. We just want to find what's the general formula for this Laplace Transform. So let's start with our definition of the Laplace Transform. So we're going to Laplace Transform of f of t is going to be just the integral from 0 to infinity e minus st f of t dt. And so in the case of our problem, the f of t, what we're really using is f prime of t. So we want to kind of substitute that back in here. So for our problem, we're going to have this integral from 0 to infinity e minus st, and this is going to become f prime of t. Now, a lot of times with the Laplace transform integrals, what we're going to want to do is use integration by parts, and this is a good case. And what I'm going to do is use the DI method, or tabular integration over here on the right. And the reason I'm doing this is because f prime of t, that's a derivative. If we have to find the integral of this, it's going to be really easy, because the integral of this is just going to be f of t. We'll differentiate the other part, which is e minus st. So taking our derivative here, we're going to have e minus st, but we just need to bring this minus s out in front. So then we have part of our solution right here on the diagonal. So this is going to give me, let's see, if we put this down, we're going to have e minus st f of t. We want to evaluate this on our bounds, 0 to infinity. Now here, this part's an integral. Well, minus times minus is plus, so we'll have plus integral, again, 0 to infinity. But now this s, I'll bring this up front of the integral. We'll have e minus st f of t dt. But the thing to notice about this, if you look at this, this is exactly the same as our definition of the Laplace transform. So this here, this is actually just going to be Laplace of f of t. But first we'll evaluate this piece over here from 0 to infinity. But we've done this in the previous examples where we really need s to be greater than 0. If s is less than 0, then this coefficient becomes positive. You plug infinity in and it diverges. So we're going to put this condition on, s will be greater than 0, but then you plug infinity in and this first piece is going to 0. Then the second part, you plug a 0 in e to the minus st, that's going to be e to the 0, or just 1. And then evaluating f of t, this is just going to be f of 0. Then we'll copy down the rest of this, so we'll have our s in front. Now there is a shorthand we can use for the result of the Laplace transform. So what we do is we say for the Laplace of f of t, we can write this as big F of s, but it's going to be some function of s. And so just cleaning this up a little bit, we have our formula for the Laplace of f prime of t. It's going to be s big F of s minus f of 0. So what we'll actually do is use this formula in some upcoming videos, because this is going to help us derive some other formulas so we can keep building our Laplace transform table. And this formula is actually critical when we have to try to solve differential equations using Laplace transforms. Okay, that's it. We'll stop it there. Thanks everyone for watching. Have a good day.